take just a second and talk to you about literals. And sometimes in the textbook, authors refer to these things as constants. Now, I don't, so I'm going to use the term literals. Let's take a look up here. Int apples. We all know that apples is a variable of type int. Apples is assigned 20. The 20 is a numeric literal. It's also a whole number. And by default, a whole number numeric literal is always stored inside the computer as an int. Float x. X is a float. It can hold a decimal point. Now, if I say x is assigned 12.4, 12.4 is a numeric literal. By default, 12.4 is considered a double. A double is 8 bytes big. X, my variable x, is a float. It's only 4 bytes big. I'm putting 8 bytes of double into 4 bytes of a float. To make this work, I'm going to go ahead and put an F here. What that F does, it tells the computer to treat 12.4 as a float so it can be stored in X. In essence, I won't get a warning message by the computer. If I went ahead and ran this program like this, the computer would actually compile this program, but I'd get a warning message, potential loss of data. The bottom line is, though, that 20 is a numeric literal. It's a whole number. It's considered an int. And 12.4 is a numeric literal. It's a decimal point value. It's considered a double by default. Now, let's suppose I have char letter. Letter is a variable of type char. It can hold one character. Letter is assigned a character literal. Why is a character literal? Because it's got single quotes around it. Excuse me, one single quote around it. And in RAM it's stored as one character. If I try to do this, this is no longer a character literal. This is a string literal because it has double quotes. That means that A in RAM is going to be stored A and a null terminator. Those 2 bytes, one for the A, one for the null terminator, won't fit into the variable letter, which can only hold a char. So that won't work. Okay. Now, in this case, I want you to know that A is a character literal, and in this case, I want you to know that this A inside double quotes is considered a string literal. And finally, I want you to know that when the computer or when the computer programmer writes the statement cout less than quote enter a value, I want you to know what cout really sees. This is called a string literal as well, and cout really sees the address of the E. So cout goes to main storage to the address of the E, and it will continue to read characters until it comes across the null terminator. When it comes across the null terminator, okay, cout will actually stop reading then. You see, every string literal has the null terminator automatically appended to the end of it. And when cout goes to the address of the E in main storage and begins to read all the characters, finally it's going to come to the character after this space, the character after that, okay, which in RAM will be a null terminator, and it will stop reading. So the cout really sees the address of the E in this case.